Hello, everyone. Welcome to episode 259 of Manage the Wild. I'm your host, Nick Madsen. Picture you find yourself at a deer capture. You have two mule deer does brought in at the exact same time. They're both lactating, they're both the same age, but there's a huge difference in body weight, there's a huge difference in size. Why? That's the question. Why is there so much different if they're from the same habitat, from the same area? That's kind of the role of nutritional ecology. Nutritional ecology is basically the science of relating an animal to its environment through its nutritional interactions. So you're looking at the different things that mule deer, elk, moose, whatever animal you are studying, tuna, coho, it doesn't really matter. You're looking at what they eat within their environment and how it affects them as they move through their environment. And that is what researchers are trying to understand is how can you have two mule deer, same size, both lactating, both with offspring, and different sizes, different weight, different fat data coming in. Nutritional ecology is understanding the dietary preferences, I guess, what they like, what they're eating. And each mule deer, based upon its own experiences, each elk is eating something a little bit different. Just like people, they generally have their favorites, but there are some that are branching off. And nutritional ecologists are looking into analyzing and looking at those plants and understanding what role those plants are going to help it as it moves through life. They're going to look at the nutritional requirements. A bull elk or a cow elk is going to have different requirements than each other. A cow elk that's lactating versus a cow elk that's not lactating going to have different nutritional requirements. So no matter what stage, what age, they're going to have different requirements, as well as the gender, male or female, because if you're a bull, you're trying to put on as much muscle, as much mass as possible, as well as grow antlers, ornamental antlers, to help you go out and beat the crap out of other males and to show your dominance so you can mate with as many females as possible. They're also looking into the nutritional requirements for maintenance. How much hay or how much vegetation or herbaceous material do you need to bring in to maintain your body size through winter? Those are all the things they're looking at, as well as how they meet those needs. How are they going about finding the different minerals, the proteins, all the vitamins they need? Are they licking salt from the road? Are they finding the minerals somewhere else? Where are they getting them? Then they start looking into foraging behavior. This is a really popular one. I've heard of some studies where, to me, it seems extremely boring. You are literally counting the number of bites an elk has in a 10-minute period. So if you have elk out on a feed row, you're sitting there with binoculars and you're just counting 1, 2, 3, time, and you're going to then calculate how many bites they had in that period of time, and you're going to see how much food that they are ingesting in a period of day. And you can then go weigh the feed troughs and all these different things that are going into it. But foraging behavior can get a little interesting too, because now you're talking about vigilance. How vigilant are they? How aware are they of the predators around them? How much time are they spending staring at something? When I go out and feed elk in the mornings and I come out with the tractor and I'm banging and the trailer's clanging and making all these loud noises, all the elk are standing there with their ears up, perked up, watching me. When a side-by-side Razor 1000 goes ripping down the road and they all pop their heads up, they are vigilant, and it's taking away from the amount of time that they can spend feeding. Seasonal variations, they also play a role, and nutritional ecologists are looking at the different vegetation and the different types and the herbaceous material that they are utilizing as they are moving through the different environments to help them understand how they are responding to the environment around them. One can look at how ungulates shift from grazing on grasses in the growing season to browsing on woody plants during the winter. So elk grazing all summer, shifting to woody plants, or mule deer browsing in the winter, and as things start to green up, they kind of shift into some of those grasses, herbs, and forbs, grasses and forbs. And you can look at those different things. But then when you see this shift, you also have to look at the digestive capabilities. What's going to happen is they're switching from one type of plant to another, one type of plant material to a different type, and what is going on with their body, and looking at all those. And that is kind of how you can understand how two mule deer, both lactating, both females, obviously, how they can show up with different weights. But there's a paper that I was reading that says take it even further. And they argue that 37% of the differences can be calculated in individual choice, not just environmental factors, whether it was snow or predators or a new Walmart got put in, but the individual choices themselves can have a far greater impact on how they come into winter. When we are going out and doing helicopter captures, bringing them back, and we're measuring all the fat, a lot more of the individual choices are going to determine how big that mule deer is, how big that cow elk is. So they're looking at, did this cow elk have offspring last spring, last summer, last fall? And if so, how much fat did they have going into winter? And then as they have another offspring, you start to measure that as well. And now you start to look at a little bit finer data that requires a little bit more time in the field. It's a lot more difficult to do. But what they're saying is if you can start to track when that elk calf is born, and you start to track and see the mother feeding it, and then the moment she starts to wean is going to make a huge difference, because you can take 3 to 6 months to wean off a cow elk or a calf elk. And if you are taking longer to wean off that calf, you're going to have a harder time putting on fat. If you are migrating 100 miles versus 10 miles, you are constantly moving, expending energy, and it's going to take a lot more time to put on that fat and time that you don't have. The individual choices are what's going to make up the difference. Just the individual differences that these elk make are going to play a huge role in and the decisions they make. Just like we as individuals, some of us are financially very successful, others are fabulous and fit and healthy, and the rest of us are just ordinary, rolling through life, barely paying bills, barely keeping it together. And it's our individual decisions, because we can all sit in the same class, but it's the roads we all take that make the difference. And that is what researchers believe is also the point for each of these animals. You can look at them as a whole and say they do this as a whole, but the ones that are excelling, these are the things they are doing to excel. So that's a little bit about nutritional ecology and why it's so important and valuable in research. Hope you guys have a great day. Stay wild.